All right, we're going to take a look at putting together some ideas that we had with different things with electron configurations and orbital notation today. So we're going to be looking at how bonds are starting to form, or how ions are starting to form, which is a precursor to the whole idea of bonding. So one of the things we're going to focus on are just the metals. So metals give electrons away, forming positive ions. So again, I would just keep some notes as you're going through this. And the way I kind of memorize this, and it might be a little bit weird, but I think of metals and nonmetals as males and non-males. So think of it as Mr. and Mrs. So eventually we're going to bond the metals and the nonmetals together. So you've probably heard that giving is positive. So it's better to give than to receive. You've all heard that with gift giving. So that's how I make that connection to giving electrons away is a positive idea. So we're going to take a look at some elements from the periodic table. Again, remember you can pause at any time if I'm going too fast for you. So we're going to start by looking at beryllium. So what I went ahead and did and wrote the electron configuration. So when we were looking at these, we are looking at the complete configuration for this one. What happens in bonding is the valence electrons are giving away. So beryllium is going to form a +2 ion, and as a +2 ion, it has the electron configuration of 1s2 because it's given these 2 electrons away. So what you might know is 1s2 we already had. That is the electron configuration for helium. So all of these noble gases are important because they have completely filled outermost energy levels, and that's what other atoms are trying to achieve, is this completed energy level, which makes them stable. So if I wrote beryllium short form, you'd see that directly, and then I would just have the +2 as the helium configuration. Okay. All right. Next one I'm going to take a look at is rubidium. And rubidium is here on the periodic table, so I went ahead and did short form for this one. So rubidium's here. I went back to krypton and then did my 5s2. Excuse me, 5s1, just because I'm stopping at rubidium. So here you can see the noble gas right away. So rubidium is going to give 1 electron away and become a +1 ion. And its configuration is then going to be Kr. So it has that noble gas configuration once it loses this valence electron. So that's why understanding what valence electrons are is really important. Next element I'm going to look at is mercury. Again, this is always a hard one to find because it's black. A lot of times if you can't find an element, check for those black boxes. We kind of automatically block those out like they're crossed out. So for mercury I have 80, so I'm going to go back to Xe, 6s2 all the way through 4f14. Remember, this one fits in this space here, and all the way out to 5d10. So I went ahead and wrote that electron configuration out. So even though this is much longer, we're going to be looking at the electron configuration of the valence electron. So mercury is going to form a +2 ion, and its configuration as an ion is Xe, 4f14, 5d10. So again, the loss of 2 valence electrons. So what you should be noticing, whatever the number of electrons lost is the number that is on the charge. Okay, my next element is going to be erbium, all the way down here on the bottom. So if I look at this one, I'm going to go back to since this is 68, I'm also going to go back to xenon, so Xe, 6s2, and then I'm going to count across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for F12. And when I write that out, I get this, and again, I am going to have a valence electron of 2 because the 6s, so remember it's only the highest electrons, so these all points in time are further away from the nucleus, so that's why they're the easiest to get away from. So you're going to see Xe again, and this time for F12. Okay. All right, there is a document in underneath this where it has some sample predictions, and there are numbered groups 1 through 4. I would like you to just do 1 and 2 for groups 1 through 4. So see if you can use your periodic table to predict what those charges are. Feel free to write the electron configurations as well.